What if everything you thought you knew about physics was wrong? From metals that glow but won't burn, to stones that spin backwards, our universe is filled with phenomena that seem to mock the very laws of nature. Prepare to question reality itself. Europium. Meet europium, the rebel of the periodic table. This rare earth metal performs an impossible magic trick. It glows brilliant red under UV light, yet it appears to defy combustion despite being the most chemically reactive element in its group. The paradox runs deeper. Europium ignites at just 150 degrees C, making it incredibly flammable, yet its compounds create the most stable phosphorescence known to science. This isn't magic, it's quantum mechanics. Europium's half-filled electron shell allows it to store UV energy and release it as visible light for extended periods, while its oxides remain stable at temperatures that would melt steel. Without europium, your smartphone screen couldn't produce true red pixels, and Eurobank notes use it as an anti-counterfeiting measure that glows under blacklight. NASA is even researching europium compounds for quantum memory storage that could revolutionize computing. Hot ice. Imagine touching a clear liquid and watching it instantly freeze into crystals that burn your skin with heat. Sodium acetate, better known as hot ice, creates this mind-bending spectacle that seems to violate thermodynamics. When you disturb the supercooled solution with your finger, crystallization spreads like wildfire throughout the liquid, releasing enough energy to reach 42 degrees C in seconds. The science behind this apparent impossibility lies in nucleation. The liquid exists below its normal crystallization point until a trigger provides a starting point for crystal growth. The process is violently exothermic, meaning it releases stored energy as heat rather than absorbing it like normal ice formation. This phenomenon powers reusable hand warmers and represents a frontier in thermal energy storage where buildings could store heat during the day and release it on command at night. Superhydrophobic surfaces. Water bounces off these surfaces like rubber balls, rolling away as perfect spheres while leaving no trace behind. These superhydrophobic materials achieve contact angles exceeding 150 degrees, making water literally impossible to stick to them. The secret lies in mimicking the lotus leaf's dual strategy. Microscopic surface roughness combined with low-energy chemistry creates air pockets that water cannot penetrate. When water droplets hit these surfaces, they maintain a composite interface with trapped air, creating enough repulsive force to launch them skyward. This isn't just a laboratory curiosity. Superhydrophobic coatings are revolutionizing everything from ship hulls that reduce drag and save fuel to self-cleaning building facades that never need washing. The Pentagon is even developing superhydrophobic aircraft surfaces to prevent ice formation at high altitudes, making flights safer and more efficient. Sulfur hexafluoride. This invisible gas is so dense you can literally pour it like water and float aluminum boats on thin air. Sulfur hexafluoride is 5 times heavier than regular air, creating an invisible liquid that pools in containers and allows objects to float as if on water. The effect is so pronounced that when you inhale this gas, your voice drops to demonic depths, the opposite effect of helium. The science is elegantly simple. SF6's molecular weight of 146 compared to air's 29 creates enough density difference to support floating objects through buoyancy. But there's a dark side to this wonder gas. It's the most potent greenhouse gas known to science, with a warming potential 23,500 times greater than CO2 and an atmospheric lifetime of 3,200 years. Despite this, it remains essential for electrical grid infrastructure, insulating high-voltage equipment that keeps the lights on across the globe. One-way bulletproof glass. Transparent aluminum isn't just science fiction anymore. This extraordinary material, known as aluminum oxynitride, creates bulletproof glass that stops armor-piercing rounds from one direction while allowing bullets to pass through from the other. The one-way effect emerges from its layered structure. A hard outer ceramic layer deforms incoming projectiles, while a softer inner layer absorbs their energy. When shot from the inside out, bullets maintain their shape and energy as they pass through the softer layer first. This material is 4 times harder than fused silica glass and costs $15 per square inch, making a car windshield worth more than the vehicle itself. Originally developed for missile nose cones, transparent aluminum now protects tent crews and enables infrared windows that work in conditions where normal glass would shatter. NASA is testing it for Mars mission applications, where equipment must survive impacts from high-speed micrometeorites. Celtic stone. The rattleback appears to mock the conservation of angular momentum, one of physics's most sacred laws. Spin this asymmetric stone clockwise and it behaves normally. Spin it counterclockwise and it performs an impossible feat, slowing down, rattling violently, stopping completely, then reversing direction to spin clockwise. This isn't magic, it's an exquisite demonstration of coupled rotational dynamics. The stone's asymmetric mass distribution creates instabilities that grow differently depending on spin direction. When spun backwards, energy transfers from spinning motion into rattling motion, then back into forward spinning through friction with the surface. Ancient Celtic priests may have used these objects for divination rituals, unaware they were manipulating one of physics's most subtle phenomena. Modern researchers use computer modeling to create custom rattlebacks with programmable preferred directions, opening applications in self-orienting robotics and space equipment. Pyrolytic graphite. Witness matter defying gravity with no energy input. Pyrolytic graphite hovers motionlessly above magnets like a fragment of alien technology. This material exhibits the strongest room temperature diamagnetism known, creating magnetic fields that oppose and repel external magnets with enough force to achieve stable levitation. Unlike normal materials that are attracted to magnets, diamagnetic substances are repelled. But pyrolytic graphite takes this to an extreme through its perfectly ordered cardon layers. When exposed to magnetic fields, electrons create circulating currents that generate opposing magnetic fields, following Lenz's law. The levitation is self-stabilizing. Displacement in any direction increases the repulsive force, pushing it back to equilibrium like a marble in a bowl. Japanese researchers recently discovered that intense light can control levitating pyrolytic graphite, moving it without physical contact. This breakthrough may explain Saturn's mysterious ring spokes potentially caused by carbon particles levitating in the planet's magnetic field. Programmable materials. Imagine materials with built-in intelligence that transform themselves without motors, electronics, or external power. These 4D printed substances can fold from flat sheets into complex 3D structures, change stiffness on command, or heal themselves when damaged. The breakthrough combines smart materials like shape memory polymers with precisely programmed microstructures that respond to heat, moisture, or light. MIT researchers have created wood that never warps by printing custom grain patterns, and medical devices that change shape inside the human body to deploy automatically. The applications are staggering. Buildings that adapt to weather, pipes that change diameter based on flow, and furniture that assembles itself. Nature discovered this first. Pine cones use programmable materials to open and close based on humidity, using 2 fiber layers running in different directions. Today's researchers are creating materials with multiple memories that can transform into several different shapes sequentially, like origami that unfolds in stages. Gumbutch.
This pear-shaped object performs an impossible balancing act. No matter how you place it, it always rolls back to the same upright position. The gumbutch has exactly one stable equilibrium point, something mathematicians believed was impossible for any homogeneous convex 3D object. Russian mathematician Vladimir Arnold posed this challenge in 1995, and Hungarian scientists cracked it after a decade of intense mathematical labor. The solution required finding the most sphere-like shape possible without being a sphere, with incredibly precise tolerances. Shape variations of just 1 part in 1,000 destroy the effect. The mathematical breakthrough led to stunning real-world discoveries. The Indian star tortoise evolved a gumbutch-shaped shell for self-righting, a crucial survival advantage when males flip rivals during territorial battles. NASA scientists now use gumbutch principles to analyze Martian pebbles from rover images, revealing ancient water flow patterns. The shape has inspired everything from America's Cup yacht hulls to self-righting robots that recover from any orientation. Dark energy and quantum negative mass. Our universe contains the most mind-bending phenomenon of all. Dark energy makes up 68% of everything that exists, yet we have no idea what it is. This mysterious force is accelerating the expansion of space itself, seemingly defying gravity's pull. Even more bizarre, quantum physicists have created matter with negative mass. Push it away, and it accelerates towards you, apparently violating Newton's laws. At Washington State University, researchers cooled rubidium atoms to near absolute zero, creating a Bose-Einstein condensate that moves backwards when pushed. Combined with dark energy's effects, this suggests our universe operates on principles that mock our everyday experience of cause and effect. The truly staggering part: empty space isn't empty. Each cubic meter contains quantum energy, but calculations predict this vacuum energy should be a trillion times stronger than observed. This worst prediction in physics may only make sense if infinite universes exist, each with different physical constants, and we exist in one precisely tuned for life. Acoustic levitation. What if you could lift objects using only sound? Acoustic levitation uses nothing but invisible sound waves to suspend solids, liquids, even insects in midair. The principle seems like sorcery. Speakers emit ultrasonic frequencies that create standing wave patterns, where pressure nodes act like invisible pillars of force. Objects placed at those nodes hover weightlessly, held aloft by the pressure of air vibrations. No magnets, no wires, just sound. Researchers have fine-tuned this phenomenon to move particles through three-dimensional space with astonishing precision. NASA investigates acoustic levitation for handling fragile materials in zero gravity without touching them, while biologists use it to study living cells in midair, eliminating the need for containers that might interfere with results. Recent experiments even suggest we may one day assemble materials molecule by molecule using only sound. In a universe where sound can become a solid wall, who needs gravity? Time crystals. They sound like something out of science fiction. Crystals that break the rules of time itself. Discovered in 2012 and experimentally realized in 2016, time crystals are a new phase of matter that never settles into thermal equilibrium. Unlike normal crystals, which have patterns repeating in space, time crystals repeat their structure in time, forever oscillating without using energy. This behavior seems to mock the second law of thermodynamics, which states that systems tend toward disorder. Time crystals defy this, maintaining perpetual motion at the atomic level. They are created by placing qubits, quantum bits, under a pulsing electromagnetic field, forming a system that flips between states in a stable, repeating pattern.
Google's quantum computer successfully created time crystals in 2021, a feat many physicists thought impossible. These entities may one day power ultra-efficient quantum computers, or even provide insight into the nature of time itself. In a way, they are the closest thing we have to a real-life perpetual motion machine, something once believed to be impossible. These phenomena reveal a profound truth about our universe. Reality operates on principles far stranger than our intuitions suggest. From levitating stones to negative mass matter, from programmable materials to self-righting shapes, physics continuously challenges what we think is possible. Perhaps most unsettling of all, the very space around you may be filled with invisible energy we cannot comprehend. In a cosmos where infinite versions of yourself might be pondering these same mysteries. The next time you see something that seems impossible, remember that in a universe this strange, maybe it isn't impossible after all.